All right, these are the notes for Chapter 2, Section 1. We are now working on solving linear inequalities. So we don't have an equal sign anymore. We'll have symbols like this, okay? This top one means less than. Okay, mathematically, that's how we phrase it. If you're given a word problem and need to write it out mathematically and use that symbol, you might also see where it says something is fewer than. And you would use, and you would use that symbol. Can't write? There we go. Sorry about that. That says than. You just can't see it there. This is greater than. You might also see it referred to as is more than. That is the symbol that you'll use if you're given either of those. This symbol here, it's less than. It still points the same way, but it has this line underneath, and that means it can also equal. So this is less than or equal to. So you might hear it referred to or see it referred to in word problems as is at most. You'd still use this same symbol. It might also say is no more than. Okay, all three of those you would use this symbol, but mathematically we say less than or equal to. Okay, if that's less than or equal to, then this is greater than or equal to. All right. In a word problem, it might say is at most, or I'm sorry, is at least. Is at least, or it might say is no less than. Okay. So, oops, follow my pen. If it says any of these three things, you'll use that symbol, but mathematically we say greater than or equal to. So, when we had equations, we would solve and we would get a solution. But with inequalities, we have a solution set. Okay, that is the set of all solutions of an inequality. Because an inequality can be multiple numbers. Lots of things will work. Now these are not bullet points. This is an open circle and a closed circle. Oh, I'm sorry. This one is the closed circle. It's filled in. Helps if I look at the picture or the dot. This one is an open circle. All right. We use a closed circle when that number is a solution. So we use this when a number is a solution. Well, we leave it open when the number is not a solution. Okay. And on this front page of our notes, that's where we're going to leave off. So go to the next page. We'll get to the others when we get to another section. And we are writing and graphing inequalities now. So if this gives me this statement, the temperature T in Sweden is at least negative 10 degrees Celsius. Well, we have T, and we know negative 10 is our number, and I need one of those symbols, okay? This says at least. And if you go to the front page when we talked about it, is at least, we used the greater than or equal to, okay? And if you don't have the front page to help you with that, you would say, okay, well, it can be negative 10, because at least it would include it, but then it's more than. It's not less than, because being at least that much, you'll be bigger most likely. So make sure it's greater than. And then when we plot this, we just need to put some points on our number line here. So at negative 10, it's a closed circle because it has that line underneath, which means it can equal that. And t being greater than means it goes to the right. All right, if the elevation E of Alabama is at most 2,400 feet, so E is less than or equal to 2,400. It can be 2,400, but no more than that. So we make sure we put it that way. And then if I do 2,000 is here, so we'll have 2,400 here. And so we'll have, 3,000 somewhere over there. Oops, that's 300, 3,000. So at 2,400, it's a closed circle, but it's less than. So we're going to go this way. Now, when your variable is on that left side, if you look at our symbols, that helps with the graphing. This symbol is like the end of an arrow, right? See my arrow over here? It's like the same. That's pointing that way, so the graph goes that way that it's pointing. This one, again, the variable has to be on the left side. It's pointing to the left, so our graph's going to the left. So if you can rearrange your inequalities so that the variable's on the left, that little trick can help you graph if graphing is a struggle for you. But hopefully you see like that the E has to be smaller, and you should always know smaller is to the left, bigger is to the right. Okay, so this asks, is 34 a solution to statement number 1? So 34 would be on the graph way up to the right, so yes, it would be. And to support that, you could say, well, it's in my solution set, or you could say it is greater than negative 10. Okay, that makes it still true. And then it asks, is 5,000 feet a solution to statement number 2? Well, again, it's off far to the right, but my graph actually goes to the left, so this would be no. It is not less than, because it needs to be less than, 2,400. Okay, so the key ideas to keep in mind when working with inequalities, you need to remember that you need to graph the direction it's telling you. Less than is to the left, greater than is to the right. Open circle if it does not equal that number, closed circle if it does. And the only time you flip your symbol is if you divide by a negative. So none of these today do that, but that is something to remember. All right, so if we go to the statements here, it gives me a statement. I need to write it algebraically and then graph it. So it says x is less than 2. So if I write that algebraically, x is less than 2. If I were to graph it, oh, that's supposed to be a 1, 2, 3, 4. So it has an open circle at 2 because it does not equal it, and it's less than, so it goes that direction. Okay, number 2, it gives it to me algebraically. I need to write it as a statement and then graph it. So if I just read this as I see it, I see x greater than 2. So x is greater than 2. That's it in words. And then if I graph that, 0, 1, 2, 3, 4, it's an open circle at 2, and it's greater than, so it's going to the right where it gets bigger. Now number 3 gives me the graph, and I need to write it algebraically and write it as a statement. So this graph, if I look, no matter what, I know I have a variable, and I'm going to have a number 2, because that's where my dot is. Now this is a closed dot, so I know it's underlined, and my graph is going less than, it's going smaller. Okay, if you have trouble remembering the direction of drawing them, my symbol here, this sideways V, the point of it is the smallest side. So it's going to be pointed to the smaller thing. Well, x is smaller than the 2. I don't know. That's just a way that it's helped me remember it when I was first learning it, but It's also an alligator is eating the bigger number, whichever way you want to do it. But also remember, if the variable's on the left, my graph is pointing this way, so my thing needs to be pointing that way too, my inequality. So if I write this out, it's x is less than or equals to. Oh my goodness, I was writing 2 twice. You can do number 4. That's actually part of the practice for today, but I'm going to do number 5 with you. 12 is greater than or equal to 5 times number. So I'm just going to write it as it says it. So 12 is greater than or equal to 5 times a number n. Okay, there's that written algebraically. Now I can't quite graph this yet because I need n. So I'm going to divide both by 5. So if I just rewrite this, I'm going to divide by 5 and divide by 5. So that is 2.4. The symbol stayed the same because I did not divide by a negative. The only thing that flips it is dividing by a negative. But again, I said it's easier to graph if you have n on the left side. So now I flip it because I'm flipping everything. So if I write n first, then I flip this, because that smaller point needs to always be going towards the n, 2.4. So I could graph it. If I have 0, 1, 2, 3, 4. It's a closed circle at 2.4, and it says less than, so it's going that direction. Okay, so the rest of this, all the way to number 16, is your practice for 2.1. I want to make a little correction here. The sum of C and a number is just supposed to be the sum of a number U, and 14 is more than 6. Remember, sum is addition, difference is subtraction, okay? And you do need to, these 3 have to be solved. So you have a variable is greater than or less than, or greater than or equal to, or something, the number before you can graph them.